Whenever, if you're seeing that potable water, right? We have to understand that what exactly is this word called as potable water? Potable water is water safe to drink, right? Safe water to drink. See, very important that we need water. We need water. We need water for for our cleaning purposes, washing purposes. In our washroom we need, right. So it's very important compound, right? H2O, which is needed. We need it for our agriculture, right? We need for industry, right? Now, very importantly, that you know what, UK has got huge amount of rains and natural water, fresh water, we tell, right? Fresh water, lakes, rivers. And what happens when the rain falls? When the rain falls, the water will be seeping down the soil, right? Water seeps to the soil and goes inside, and it will be stored in rocks, spongy rocks. This is very important. It will be getting stored in what? Spongy rocks. Spongy rocks means it's not like a sponge that you can squeeze, right? Spongy means fine hairs are there, million times finer than our hair, right? Fine hair, like rocks, huge rocks. It's a huge area of rocks, huge depth of rocks, where the water gets stored. This is called as aquifers, right? Isn't it? Fine. So aquifers are what? Aquifers are rocks under the soil, which accumulates the water. Now, when we need groundwater, we have to drill a pipe over here and we pump it. Now, this is a very important part. Now we have to know some important things which happens when the water falls on a ground, right? In the ground, in the soil, we have got what? In the soil, we have got bacteria, right? We have got bacteria, isn't it? We have got the viruses, bacterias mainly. Why? Because we see that there are many degradation happening, right, in the soil. Many degradation happening. Suppose some animal has died, or some waste has been put, right. So there are bacteria which is, means these bacteria also get solubilized. Second, there are many compounds, right, which also gets gases, which also gets dissolved in that water, right, isn't it? Also get dissolved in that water, and they get stored in the aquifers. So this water which you drill out, right? We are blessed in UK or in India, where we have got natural water. We have got huge amount of natural water, right? In the form of lakes, in the form of rivers. Now, this is very important, that the water which is there will be containing microorganisms, soils, particles, gases dissolved in it. So we have to make sure that this water is cleaned. So how does potable water obtained? Potable water is obtained by different means. Suppose we make a reservoir. Suppose from rivers and lakes mainly, it is actually taken. Yeah, groundwater is also there, but maximum of our water comes from lakes, rivers, right? Natural fresh water. Now, if you open the book, please open the book quickly. You try to make a line over here like this, right? Now mark it one. First we do what? First we take a reservoir, and over here we are storing this water. Now the first part is that we pass it through what? We pass it through a mesh of metal bars, right? Big mesh of metal bars. This is mainly used to what? This is mainly used to catch the large objects, right? Next part is that water over here, which is coming, contains big particles, right? Big soil particles. And there are finer soil particles. This thing you have to know. What are this water come? This water contains big soil particles, fine particles, which are suspended, right? Fine particles, you cannot settle it, right? They're suspended. They keep actually suspended. And also we have got what? We have got microorganisms from the decaying matter of the soil, isn't it? Now, what we do in the first step, this is we use a large mesh. Second step is that we take a settlement tank. In the settlement tank, we do what? We let the soil and the sand settle out, the big particles, right? And after that, we are passing into the third tank. You mark it 3 over here. That will be better. In the third tank, we are doing what? In the third tank, we are taking some coagulating agent. This is gone now. The bigger soil particles is actually by the gravity, it has settled down. And after that, it will be coming to the third tank. In the third tank, we are putting what? Coagulating agents, such as aluminum sulfate, such as lime, right? This we put, so that the finer particles, they defy gravity, right? They will be defying gravity. They won't settle down. The finite particles, this coagulating agent, aluminum sulfate. So aluminum sulfate is what? Al2 SO4 3, and lime, calcium hydroxide, right? These two we mix it so that the finer particles, they clump it into a larger particle, right? Larger particle, and they settle down. So this is a very, very important fertilizer also we can use, right? This thing, sludge. This sludge is what? This sludge will be taken out and it will be dumped in the landfill site. Now, after this, the fourth step is what? Please draw a line in your book. This is page number 208, I guess, right? Draw a line over here so that you are getting to know that this is the fourth step. In the fourth step, we are doing what? We are passing this water where the big particles is actually separated out, the fine particles is actually clumped together, and after that it is piped to what? It is piped to a particular fourth tank where we have got a filter made up of sand and gravel, isn't it? The filter made up of sand and gravel. This sand and gravel will be eliminating any further mud or grit. Any mud or grit we're having, it will be settling down. It will be eliminating out. Now over here, write 5. Isn't it? Very important that you mark it. Please open the book. Please, everybody. This will be coming in an exam. 6 marker, 100%. This water looks very clean now. See, this water looks very clean, sparkling clean. But is it totally clean? Has this microorganism been actually separated out? No, we have not separated out these microorganisms, right? Which is there in the dead, decaying bacterias on the soil. So this still contains harmful bacteria, which are very devastating. What we do next? We add what? We add a chlorine over here. See, there are 3 things you have to add over here to kill the bacteria. First is that if the council is having ample amount of money, then they add ozone, right? Ozone is much more safer. If the council is not, or any country is not having that fund, they use chlorine. Chlorine is a toxic chemical, right? It will be killing any living microorganism, right? If added above a certain amount of concentration. This is also very important. When you went to swimming, can you smell that chlorine was added inside that particular swimming pool? Because you had what? You had that particular, you had that people going around with they can be infected also, bacteria can be there. So swimming pool, we add chlorine. You might have smelled chlorine there. Now next part is that after we have added the chlorine, right, we can also add ozone. Third, we can also pass it through ultraviolet light. This is the best part. Ultraviolet light, we can use ultraviolet light. So chlorine is usually added in the fifth step, right? So in the first step, we store it in the water, we pass it through a metal grate, and after that will be the large object, that leaves and the branches, they eliminated. Then the heavy particles are settling down in the settlement tank, number 2. Then the fine particles, they cannot settle due to defying of the gravity. We add anticoagulating agent over here, which makes the fine particles into lump, and they will be settling down. And next we pump it in the fourth tank, where we pass it through a sand and gravel, and finally it comes to the fifth tank, where we are killing the harmful bacteria. After the harmful bacteria is actually totally killed, sixth work is what? You mark 6 over here. The pH of the water has to be tested. This is very important, right? Because ultimately we have to drink the water, right? Somebody can drink the water. So the pH of the water has to be checked. And if the pH is not okay, we have to treat the pH, right? And the pH of the water has to be checked. And after that, it is pumped to houses, offices, factories, right? Isn't it? So this is a very important portion we have to know, right? This is the portion which you'll be needing, right? Now, come to the part that, what, we are lucky to be in UK or in Asia, where there are ample amount of rain, there are rivers, there are lakes. But have you thought of that? What happens to those countries which do not have rain? There's no rainfall which happens. No rainfall happens. They don't have any groundwater. We are lucky. They don't have any groundwater also. So those countries do what? Those countries rely on the seawater, right? So we'll be going to the next potable water section. This potable water section is for those which has got rivers, lakes and all. Next, we are going to the potable water section of the seawater. Those countries which do not have ample amount of groundwater and all, right? So we are coming to the seawater. In the seawater, we have to see that when we see the seawater, right? Seawater contains salt, right? It contains salt, isn't it? NaCl plus water, right? So this is a very important part. We know that we have to somehow separate the salt or the NaCl. Simple, right? But you have to see that What are the ways by which we can do it? Now, please try to take out your pen quickly, or sorry, take out a pencil. This is page number 209, I think. Mark it over here. One, right? One. We learned earlier that when we had NaCl plus water, right? Please try to message me now. So NaCl is a solute and H2 is a solvent. Now my question is that when you want to take out the solvent from the solution, which process do we use? Do we use crystallization? Do we use simple distillation? Or do we do fractional distillation? A question's coming up. Please try to message me. If you have got NaCl and water, we want water. We don't want the solute. We don't want the solute. We want the solvent to be taken out. If you want to take out the solvent from the solution, what process we have to do? Crystallization or simple distillation or fraction distillation? Please try to message me. Please try to message me. Question, please. Please try to message me. What is the process we take? Please try to send me. Yes, very good. Very good. Very good. Yes, simple distillation. Wonderful. Wonderful. Wow. Wonderful. Very good. Yes, simple distillation, right? Wonderful. 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 Fastest finger, right? Very good, right? Very good. Very good. Very good. Yes. Yeah, reverse osmosis, same thing as reverse osmosis. A reverse osmosis is something different, I'll be telling you. Very good. A question coming from that. What is reverse osmosis? Yes. So have you opened the books, please? Desalination. I'm telling you what. I'm telling you something different. Yeah, yeah. It's something different, right? What is desalination? Desalination is the process by which we are trying to converting salty water into the particular usable water, right? Desalination is a broader picture, right? Yeah, we can take that. Okay, that reverse osmosis is also a desalination process we can take, but yes, we can take. Yeah, we can take that. Desalination is a larger water. Is it clear? If you want to take out the solvent from the solution, we do what? We do simple distillation. Now, if you want to take out the solute, this is very important. If you take out the solute from the solution, what we do? We do crystallization, right? That's very important, right? We are doing crystallization. Now moving to this part, we have to know that this is the first process, right? We can do simple distillation. But we have to know that simple distillation is quite an expensive process. This is a very important part, right? It's a quite an expensive process, right? Quite expensive process. Why? Because it needs energy, it needs electricity. It's a huge cost. It's a huge cost. We have to heat it, right? In the simplification, can you recall? We take that substance and we heat it. We boil it to the boiling point of water. Then we pass it through a condenser, right? And it will be condensing, right? So it takes energy. Now you mark it 2. Now this is 1. Mark it 2. Flash distillation. This will be coming in exam. What is flash distillation? Flash distillation is a process by which we are boiling water under reduced pressure. This is very important. We take a device where we somehow reduce the pressure of the water which is there. When we reduce the pressure, water will be boiling below 100 degrees centigrade, around 90 degrees centigrade. See, it helps us to save us huge energy costs, right? So this is called as flash distillation. You can mark it 2. Now, all these processes, as a student has messaged me, wonderful. Is desalination similar to reverse osmosis? Yeah, desalination is a broader term. You can write down this. Thank you so much to the student who has sent this. Desalination is a broader term. What is desalination? Divided desalination. What is salination? Desalination is to take out the salt, converting salty water to the potable water. Is it desalination? So that's a very important portion we have to learn, that whenever we are seeing that we are trying to purify, when we try to purify the salt water, right? What we are seeing, that we are seeing that we are using what? We are using distillation, or we are using flash distillation, or we are using what? We are trying to use the process of reverse osmosis, the third process, right? Everybody's clear? Fine. So that's a very important part we have to know, that whenever we are seeing the UAE countries will be taking water from the seawater. Then we have to input simple distillation or flash distillation. Flash distillation is the process by which we get particular water at reduced pressure. And finally, we can do reverse osmosis. Now, what is reverse osmosis? Now, this reverse osmosis, this is clear to you. This is all from the sea water, the Gulf countries, the Arab countries, which do not have fresh water as we do. Please switch on the recording site. I'll be sending the recordings to you all. Go through the recordings. Just go to the recordings. Do it right. Now, see. Now, if you're trying to convert water from sea water to water, the third desalination process, right? Yes, is called as what? Is called as reverse osmosis, right? So this is very important. What is reverse osmosis? Reverse osmosis is a process by which we pump in. Now, this is very interesting. See, what is reverse osmosis? Suppose when you go to India, there are many portable reverse osmosis, all the machines in your relative's house, right? You might have seen Aquaguard, right? Aquaguard is quite famous. What is reverse osmosis? Reverse osmosis is the process by which we pump in. We take the water and we use a heavy pump. We use a heavy pump and we pump the water through what? We pump the water through fine membranes. Is it clear? This will be coming. We pump the water through fine membranes. These fine membranes will be having a slot, a specific slot, right? A specific pore size, which will not allow NaCl to pass, isn't it? NaCl has got a size, right? It has got a size. It has got a radius, right? Water is smaller than NaCl, right? NaCl is a little bit bigger. In the reverse osmosis, we use membranes where we pump water through membranes. These membranes will be having what? This membrane will be having fine holes inside it, and this will be trapping all the salts, and we are getting water over here. Now, this process, you know what? This process is much more cheaper than distillation or flash distillation. Why? Because we are not using any heat over here. But yes, what are the negative points? So this is clear to you. First process is simple distillation. Second process is flash distillation. Open page 209. Third process is reverse osmosis. In the reverse osmosis, we are taking the seawater, pumping through membranes. These membranes will be having very fine pores, right? Very fine pores. And we pump through it. And what happens? We are getting the water over here, right? Clean water over here. But what's the negative point over here? The negative point is, you can mark it over here. The negative point is that although we are saving a lot of energy than the distillation process, but we have to frequently change the pumps and the pipes. Why? Corrosion of the pumps by the salty water is a problem. Just try to write like this, right? 1, 2, 3. As a student has wonderfully mentioned to me, I'm saluting the student, amazing brain, that he asked me that is desalination similar to reverse osmosis? Yeah, desalination is a overall name we gave to all these processes. Also, we can coin. Ultimately, when you're converting salty water into potable water, what is potable water? Water fit to drink. You can write this down. What is potable water? So we learned over here. A student joined late, so no worries. I'll be just sending this recording to you, right? Don't worry. So we have got two aspects. One aspect is that we are lucky to be in UK, in the fresh water or in the lake water we are using through this process. The lake water and the lake water and the river water, you are using this process. And second process is that we are taking sea water for those countries which are not having rainfall or any water. We do distillation. Simple distillation is better term. Flash distillation we are doing, right? And we are doing reverse osmosis. All these processes comes under a larger process called as desalination. Desalination is the process by which we are converting salty water to potable water, right? Now, I'm just moving on to the next part, right? That is called as what? Wastewater treatment. See, guys, this will be coming in an exam. So be aware of this. Will be coming in an exam. So switch on the recording, please. Go through it. Thank you so much. Now, I'm just coming to the part of the treating of the wastewater. Now, when we see, if you see that when we see that wastewater, right? Wastewater is very, very important for us to treat, right? Before we dispose of. This is very important. This is not done properly in the Asian countryside. Yeah, already have recording it, right? Anyways, you can record it, right? Ryan, you can record. I already have recording it to you. I'll be sending this recording to you also, right? Sorry for it. If somebody has not got the recordings of yesterday, I'm really sorry for it. Just 1 minute. I'm just sending the recordings to you. Whenever we are seeing the sewage treatment, just download the videos which I've sent for yesterday, right? If anybody I've missed to send, right, please download the videos which I've sent you the Zoom chat. Now, in the sewage treatment, we have to see that what happens in the sewage treatment. See, we have got wastewater. We have got wastewater in the dishwaters, in the sinks, in the bathrooms, in the toilet, right? Isn't it? Factories also, they try to emit sewages. Businesses also emit, right, wastewater. So this entire water which flows down from our dishwashers, sinks, bathrooms, toilets, businesses, this is called as sewage, right? Isn't it? Sewage, right? Is it clear? Now we have to treat this. We have to treat this sewage before it is dumped into the sea, isn't it? Before it is dumped to the sea, we have to treat this, or rivers. We have to treat it, because otherwise all the marine organisms will die, right? So we have to treat this. Now, in treating this, now we have to go to a very important portion over here. See, if you can open your book, please open your book over here. See, the first part is that the sewage comes to the pumping station, right? We have got a toilet excreta also, right? Large particles of the toilet excreta and all. So this is coming to the pumping station. In this, from the pumping station, we are passing it through a screening process, right? In the screening process, what we're doing, we are separating out the large particles which are there, right? Our human waste and all, right? Large particles and other things, right? um, some nappies and all, anything, right? Which we are filtering out over here, right? We are screening over here. Next part is that it comes to what? It comes to a primary sedimentation tank. In the primary sedimentation tank, what happens? It is like a circular tank where solid particles, residuants are allowed to settle down, right? Clear? Thank you so much. You're back. Okay, thank you so much. Okay, I just revised that particular part for the student, right, who has joined late. So what is sewage? What is sewage water? Sewage water is the wastewater from factories, dishwashers, bathrooms, businesses, right? They have to be treated down before we are disposing onto the sea and all, right? Because marine organisms will be, aquatic organism will die. So we take the sewage water, we pump it in the pumping station, right? Please put your headphones on. Please stop me if you don't understand anywhere. Then we pass it through the first process, that is screening. In the screening process, it traps the large solid objects and the grit. Next is that we are passing to a primary sedimentation. In the primary sedimentation, in the primary particular sedimentation, we do what? In this primary sedimentation contain two tanks, right? You can write it down. There are two tanks. In the first tank, what happened? The solid sediments are allowed to settle down. We give time. And what we do, we take baffles. Baffles are rotating at a very slow speed. Understood why we are using particular baffles? Because this baffle will be moving at a very slow speed. Anybody can tell me why do we use these baffles at a very slow speed, not a high speed? There are baffles. So this is the primary treatment happening. Primary treatment involves the first tank where baffles are used. These baffles are running at a very slow speed. What's the answer? A baffle. So one student has messaged me that what is a baffle. I'm just appreciating the student, right? Good that you have asked, right? Very good, right? Very good. Baffles are what? Baffles are having a fan like thing, right? Like this. Understood? A fan like fins which are there, and there's a pump, there's a motor over here, and it rotates. Understood? What are baffles? Or paddles, you can tell. Paddles, right? Paddles also you can use. Paddles. We use paddles like a fan. It's like a fan which you use in India, right? Suppose in the fan which you use in India, similarly, we are having paddles, isn't it? What is the work of this? Is it clear to you, right? Just at a hand holding the student, right? Is it clear to you, right? Is it clear? Thank you for the student who have asked me. Everybody ask me. Make it a one-on-one session, right? Please. Thank you so much. Thank you so much, right? Thank you so much, right? Thank you so much for asking. Always ask me like this. Send me a message. We use paddles. We use paddles at a very slow speed, right? Very slow speed. We are using a paddle. When we are using paddles at a very slow speed, what happens over here? All the solid particles, right? They will be churning and will be coming to a coming to the bottom, right? Is it clear? Is it clear to you? It will be making sure that the solid objects are coming to the center of the tank. Is it clear why we are using baffles over here? They come to the center. Slowly we move, right? See, this is the tank, right? This is a tank which I'm having over here, right? We are using paddles over here, right? And the paddles will be making sure that it comes to the center. This is the first part of the primary treatment. In the second part of the primary treatment is that it moves. You can write it down. You can mark like this. Understood? You can mark like this. This is the primary treatment, right? Clear? In the primary treatment, we first put it into a circular tank containing paddles. Second part of the primary treatment is that we are passing through, we are taking this water and putting into a tank where we are adding what? We are adding harmful, sorry, good bacteria over here, right? Or enzymes we are adding. Is it clear, everybody? In the second tank, what we are doing, we are feeding useful bacteria over here. In the useful particular bacteria, right? What happens? We are passing air through it. So it is aerobic digestion, right? Clear? Is it clear to you? This is primary sedimentation. Next is that we are passing the water where the solid particles have come down to the second tank. We are using enzymes and other good bacteria in presence of air. This is important. In presence of air, right? Air, aerobic digestion. Remember this thing. What happens over here? It will be breaking down. It will be breaking down any solid particles, any other particles which are there. It will be making it smaller. Now, after that, what we're doing, we're passing through the secondary sedimentation. In the secondary sedimentation, we are doing what? In the secondary particular sedimentation, we are allowing the finer particles to settle down further, right? Clear, everybody? Is it clear to you? And after that, what we're doing? See, over here, I forgot to tell you. This solid particles in the first tank, right? Where use the paddles, right? We are taking this and we are putting in the sludge digestion, right? Isn't it? In the sludge particular digestion, what we're doing? We are doing anaerobic process. You can write down over here. Clear? So over here, what happens in the primary sedimentation? We see that the water effluent will be looking very clean, and it will be containing harmful microorganisms, right? Next part, we are treating with the biological treatment, right, to break down any harmful particular microorganisms or any large particles, and coming to the secondary treatment, right, secondary sedimentation. In the secondary sedimentation, we are further allowing the particles to settle down, the finer particles, right? Is it clear? Here, always to understand that we are using anaerobic digestion. In the anaerobic digestion, we are doing what? We are adding oxygen to it, right? We are adding oxygen. We are bubbling oxygen because all the bacteria we are using over here, good bacteria and the enzymes need air. So anaerobic digestion. Next, it come to the what? Next, it come to the secondary treatment, right? Isn't it? In the secondary treatment, what happens? The useful bacteria we added over here, right? We added some useful bacteria over here. These useful bacteria along with the fine particles are allowed to settle down, isn't it? Useful bacteria we have to need, right? The enzymes we have used it. So what we do, we separate the useful bacteria and again put it into this biological treatment tank. And the finer particles we are putting into the sludge digestion. Is it clear, everybody? Fine. Did you get my point? Now, this secondary treatment did what? The secondary sedimentation, we settle down the bacteria which we used over here, and the fine particles is put into the sludge digestion along with this over here, right? And the water is now clean, right? But it contains harmful bacteria. So it will be passing through same process. We are killing bacteria by what? In the potable water, we use chlorine, we use ozone, we use ultraviolet light. Then we kill the bacteria, final bacteria, and we then dispose it to the lakes and the rivers. Now, from over here, the solid particles which were there, and over here, the remaining finer particles which were there, this is coming to the sludge digestion. Now, remember one thing. In the sludge digestion, we are trying to breaking down the larger particles and the finer particles further in an anaerobic way. Please note down this. We are doing it in an anaerobic way, right? And this sludge is used as a fertilizer. It can be used as a particular biogas. It can be used as a solid fuel. It can be dumped in the landfill sites. Is it clear? This is like a very important resource we are getting, right? The sludge which we are trying to separate out, right, from here contains organic matter. This also contains organic matter, right? Our human excreta, everything, right? So this is further broken down by anaerobic process. And all the organic matter, including human waste and all, they are coming over here, right? Finally, we are breaking down. And we are seeing that this particular process, right? we are getting this sludge. This sludge can be, this question will be coming, this sludge can be used as what? This sludge can be used to burn also. We burn this sludge to get what? To generate electricity, right? Isn't it? We generate electricity also, right? This sludge, right? This sludge, you'll be seeing that this also contains what? This also contains biogas. The biogas is what? Methane. This methane, and it contains sulfur dioxide. Understood? Right? Understood this part. What are the products? This sludge addition, we can take as fertilizer. Biogas is what? Biogas contains methane and sulfur dioxide, or hydrogen sulfide also, right? Mainly methane and hydrogen sulfide. This hydrogen sulfide is very pungent gas, very bad smelling, right? What we can do, we can directly take these gases, and we can generate electricity by actually burning them. Or we can also do what? This methane we separate out, and because this H2S gas is very pungent gas, it's like a rotten egg smell. So what we do, we take out the methane, and we can also we can also send to the homes for the kitchen, right? Clear? So this is the process we are doing over here, right? Thank you so much. So now coming to the part of what now to go see, um, describe what takes place in the primary treatment tank. State two uses of the sewage sludge. See what takes place in the primary treatment tank. In the primary treatment tank, we are taking, yeah, see the question, primary treatment tank, what happens in the primary treatment tank? We are having the first tank containing which containing paddles, which will be making sure that the solid particles come to the center of the tank. And after that the water is pumped to the second tank, right, where the solid matter is visible, and the effluent still contains harmful microorganisms, right? So we are treating with a biological treatment, and we are doing aerobic process. This is the answer. Now they're asking that what is the uses of sewage sludge? This sewage sludge, the sewage sludge can be used as fertilizers. They contains methane gas and H2S, so it can be used to generate electricity. It can be used as solid fuels also, or else the remaining part can be dumped in the landfill sites. Or we can do what? Methane plus H2S. We can separate out the H2S gas because it's very rotten egg smell. We can take out this methane and pump to the kitchens, right, where they can be used to cook food. Fine. Whenever you go to ASDA, I'm telling you, whenever you go to ASDA, Green Height ASDA, just there's a petrol pump, right? Just behind the petrol pump, you're having this plant. You can see that, right? This sludge, ultimately the human waste is compacted, right? Anaerobic treatment is there. Just stop there in the ASDA greenhouse. At the back side, you'll be getting this plant which is there, right? Which is active, which is there. You can see that plant there at the back side. Now, is it clear to you? Now, I'm just coming to the next part. Is that what? Extracting metals from ores. Now, this is a very important chapter we have to know. Now, if you see, when we talk about the ores, we learned earlier that ores can be of two types. Can anybody message me what are the two kinds of ores which are there? I'm opening the paintbrush. Can you message me what are the two kinds of ores? What are the two kinds of ores? We know. Thank you. Everybody try to message me. What are the two kinds of ores we know? Wonderful. Amazing. Good. Very good. Wonderful. Very good. Very good. Very good. The two kinds of ores we have, what? Ores are what? What are ores? Ores are rocks. Ores are rocks in which the metal compounds are formed. What are ores? Ores are rocks from which the metals can be extracted profitably, right? Isn't it? That there are two kinds of ores. One is called as a high grade ore, and one is called as a low grade ore. Is it clear? Fine. There are two grades of ore. Ores are rocks from which the metals can be extracted profitably. Ores can be of two types. Ores can be low grade ore. Ores can be high grade ore. Now, what is a high grade ore? High grade ore is a ore where we are having more amount of metal which is there, more percentage of metal. What's a low grade ore? Low grade ore is a ore where we are having very less amount of the percentage we are there. Now, see, any mining industry, they are very, very important to know. Mining industry has got a business there, right? They have to build the factories there, offices there. They have to build the hospitals there, colleges there, right? They have to build all these colleges, offices, factories, right? Isn't it? So this is very important, that mining industry is a labor intensive. They have to hire laborers also, build their houses also, right? build schools, colleges for the laborers and the employees. So mining industry is a very huge amount of financial investment they have to give, right? Isn't it? They cannot use low grade ores, right? They have to sell that ore, right? They cannot use low grade ore. But we know this important part, that ore is a non-renewable source, right? It is a non-renewable. It's non-renewable. It's fixed. Mother Earth has got fixed amount of minerals, right? Fixed amount of ores. It won't multiply, right? So now think of this. Everybody will be taking out the high grade ores. And what will be there for the future generation? The sustainability aspect. We will think about the future generation. So what is the future generation going to get, right? Because if we use the high grade ores, what they can be, what they'll be using. So can we use this low grade ores? Low grade ores nobody touches. Nobody touches this low grade ore. Can we use this low grade ore? Yes, we can use this low grade ores. Low grade ores are extremely financially not viable. 2% or 3% of the metals are there. Yes. In your GCSE, we have got a case study of what? We have got a case study of low grade ores of copper, right? Isn't it? There are other low grade ores of iron. We have got zinc. We have got magnesium. But in your syllabus, we have got what? We have got syllabus of the case study of the copper low grade ores, right? Just remember one thing. This will come in your exam, either phyto mining or bioleaching. Now, now, see, when we take the low grade ore, copper low grade ore, copper low grade ore can be extracted by two processes, right? One is called as a phyto mining, one is called as a bio leaching. Is it clear, everybody, right? One is called as a phyto mining and one is called as a bio leaching. There are two processes which are used. Now, in both the processes, the final four steps are similar, are same exactly, right? Final four steps in the both. Please try to note this down. We are taking phyto mining, we are taking bio leaching. In both the steps, the final four steps are similar. Remember this thing, right? Final four steps are similar. Remember this thing. Now, in the phyto mining, what we do, now remember, please try to note down this. In phyto mining, what we do, we take the low grade ore which is in the soil and we do what? We plant trees, right? Please note down this, we plant trees. See, remember one thing, low grade ores are not financially viable, right? It's not financially worth enough, right? We have to employ labor, right? We have to employ labor, we have to employ machineries, right? So we have to make sure that whatever we are using should cost less in this process of extracting low grade ores. Is it clear to you? This fundamental is clear, that whatever we are using in this process should cost less. You'll be seeing that instead of taking the fresh iron, right? Fresh iron, we are using scrap iron, right? That's a hint I'm telling you, right? We have to use scrap iron for a step which is there. Now I'm coming to the part. In the phyto mining, what we do, we plant trees. After planting the trees, what we're doing, we let the trees grow. After 2-3 years, what happens? See, the copper ores are there, the copper 2 plus ions are there, right? Understood? This copper 2 plus ions in the low grade ore, they will be absorbed by the trees. We cannot just plant any random trees. We will be, this is not in the book, we are planting specific trees which will be absorbing copper ions from the soil. Is it clear? Which will be absorbing copper ions from the soil, and this copper ions will be going through the trees and getting deposited in the bark, stem. Everybody is clear? Please do to message me. Is this clear to you? Please do message me. I'll be handling everybody, right? I'll be handling everybody, right? In the process by which we are doing it, what? In the process by which we are doing it, that we are planting trees, right, on the low grade ore soil, and those trees are very vital for us to absorb the copper ions. After 2-3 years, what we do, we cut this plant. After cutting this plant, we are doing what? We're taking the plants and we are burning it, right? We're taking the plants, cutted plants, after 2-3 years, we are burning it. When we are burning it, what happens? The carbon will be getting burnt away, right? Carbon plus oxygen gives you carbon dioxide, right? It will be burning away. Leaves, branches, whatever. But inside the branches, inside the barks or the stems, the copper ions will not burn away, right? So in the ash, what we are getting? We are getting the carbon burnt and the copper ions which are there, right? Clear, everybody? Fine. Now from this step, the step is similar to the bioleaching, right? From this step, what we take the copper ions containing ash. and we dissolve it into sulfuric acid. You can note down this. We're taking the copper containing ash and we put it into sulfuric acid. Is it clear? This process is called as leaching, right? Slowly, what happens when we dissolve this for a larger amount of time, right? Copper will be slowly leached inside the sulfuric acid and will be getting converted to copper sulfate. Is it clear? It is clear to you? Till over here it's clear. Copper ions in the ash, they will be leached to the this process will be similar to the bioleaching also. Please note down this. The sulfuric acid will be leached and getting converted to copper sulfate. Now here's the trick. What we do, we add scrap iron. I told you now we have to use processes which will be easier for us, cheaper for us. We use scrap iron. Now we use scrap iron in this copper sulfate. Why? Because scrap iron we are using because it will be very throwaway prices we are getting, right? This, we know that more reactive metal displaces a less reactive metal. So this iron will be displacing this copper, right? And what we are getting? We are getting FeSO4 plus copper. Is it clear, everybody? This is the first step, second step. This step is similar to bioleaching, right? So note down this. After getting the leached copper sulfate solution, we will be adding scrap iron. The scrap iron will be doing what? The displacement reaction. Iron is higher than the copper. And we're displacing to FeSO4 plus copper, right? We get the copper. But here copper is 95% pure approximately, right? Isn't it? We take the copper and after that what we're doing? We are using electrolysis to refine it. This step is the third step, electro refining. Is it clear to you? And we're getting copper which is almost 99.99% pure. Everybody is clear? If anybody has got any question, please tell me. Again, I'm telling you, we take the plants, we grow the plants, specific plants which absorbs copper ions from the low-grade ores, copper low-grade ores. Yes, everybody message me, please. Thank you so much. I'm trying my best to cover maximum syllabus side which is there, right? But please help me if you want to say thank you to me. As a mark of respect, study from the book. You have got the time. Thank you so much. Whatever is I'm asked you, you have to go from the CGP guidebook and note down. Janki, just to type a message. You have to revise these chapters from the CGP guidebook. Please note down. C 14.1, that is finite and renewable resources. LCA from C 14.5. Reuse 14.6. 15.4.
Could you just say that?
Yeah, again. 14.1, 14.5, 14.6, strictly from the CGP book. 15.4, composites. Isn't it? These are strictly from the CGP book. And if you want to go through, suppose safe water and finite the wastewater, you can go through, but you have got an idea already. You've got a strong idea now. See 13, 14, 15, if you want to go to the CGP book, you can, but my specific chapters are these. 14.1, 14.5, 14.6 must be from CGP book. 15.4, and you can rest other chapters if you want to go C13, and you can write on comma, C13 to C15. You have got shortage of time, go to the CGP book, right? But not the paper number 1 from the CGP book, I'm telling you. It will be devastating. It'll be crashing down, right? Thank you so much. My specific chapters already told you now. Is it clear, everybody? Thank you. So what we do, we take phyto mining. In the phyto mining, we grow plants in the low-grade ores. And after that, we are cutting the plants. We are converting into ash. We're taking the copper ash containing the ash. We're dissolving H2SO4. This is the same step in the bioleaching also will be coming. We are getting copper sulfate solution, leaching happening. We take copper sulfate solution and we displacement reaction, we adding scrap iron. This is very important, scrap. We get FeSO4 plus copper. Copper is not 100% pure. In order to make pure copper, we are adding electrolysis. Done? Now, I'm just coming to the part of bioleaching, right? This will be coming in an exam, I'm telling you. 6 marker or 4 marker is a must. It will be. So bioleaching, I'm going. In the bioleaching, what do we do? In the bioleaching, we are taking the copper low-grade ores, right? Understood? Now, this is a thing you have to memorize. We feed the low-grade ore, we crush the low-grade ore, and we make a solution. right? Which we make a slurry. Now, here I'm going slow. After making a slurry of the low grade ores, we clean the soil and mud by washing it. Indeed, you know how do we do concentration of the ore? We take the ore, we crush it, we wash it with water so that mud and sand can go away. And after that, we are taking the concentrated low grade ore and we're making a slurry. To this, we are adding bacteria. Understood? Bacteria. Clear, everybody? And by a complex process, you can write down, please write down, by a complex process of biological and chemical process, right? Chemical process. By complex process of biological and chemical process, what happens? The copper low grade ores will be converting to copper 2 plus solution. Is it clear? Understood? Clear? This thing you have to memorize. By leaching, we take copper low grade ores. After washing the mud and all the sand and all, we put bacteria and make a slurry. Slurry, I hope that you have known, right? Lassi. Lassi is a slurry. That per yogurt milk, right? Yogurt milk drink you do, right? The slurry. And we add bacteria to it. This thing you have to utter and memorize. By a complex process of biological and chemical process, it converts the low grade ores into copper ion solution. Is it clear? This line you have to add. After that, I told you, same process. We take the copper ion solution and we add H2SO4. See, 1 to 4 step is same. I told you, this you have to memorize. We add bacteria, it converts by biological process and complex chemical process, convert to copper ion solution. Then this step becomes, right? See, same as phytomining. We add H2SO4, first step. It will be leached to copper sulfate. Then what we do? We add scrap iron. Why scrap iron? Because we have to make that process very much cheaper, right? We add scrap iron. That scrap iron will be undergoing displacement reaction and we're getting FeSO4 plus copper. Is it clear? Then finally we are doing electrolysis. Is it clear? Just help out. You open page number 213. I'm telling you. Everybody is clear? Please switch on the recording when you're doing the questions, right? Go to page number 213, everybody. Mark here e to the power infinity. This entire e to the power infinity, mark with the pencil tip here. 213, I guess, this page number, right? This will come. Clear? The 1 to 4th step is same, right? H2SO4 adding, we are getting copper sulfate. Copper sulfate, we are adding scrap iron. We are getting iron sulfate plus copper. This copper is not pure. So we do electrolysis to purify it. That's it. Is it clear? Now see, they're trying to, we have to know some traditional method of extraction. This is the low grade ore extraction. What is the traditional method we do? The traditional method we are doing what? Copper ore from the high grade ore, not the low grade. High grade, we have done the low grade ore. The traditional method by which we doing that we are taking the copper ore, we're taking the copper ore, and we are treating with H2SO4. Same thing, right? We are treating with H2SO4. The copper we are taking, we are treating with H2SO4. Then we get copper sulfate, right? Understood? Now this copper sulfate is ultimately, copper sulfate will be finally extracted to copper. Traditional low high grade ore we are doing, right? Isn't it? Now we have to know that copper ore can also come in copper sulfide form. This part you have to know. Always learn this trick that copper ore can be copper oxide, copper sulfide, or copper carbonate. Note this part, right? This is the ores. It can be in oxide, it can be sulfide, it can be carbonate. Always learn that any metal ore, if it is in oxide form, it is very easy to extract the metal. Note down this. This is not then the book. Any metal ores are what? They're compounds of metal. It is mainly copper. It can be metal oxide, metal sulfides, metal carbonates. You can note down. Mainly the ores come in oxides. It is very easy to extract the metal from the oxides. But if you have got sulfide ore and carbonate ore, what we do? This is the process you have to know. We can go for heating with oxygen. Why? We are converting the sulfide or the carbonate ores into copper oxide. Is it clear, everybody? This thing is clear. The high grade ore I'm doing, right? It can be oxide, it can be sulfide, it can be carbonate. Oxide is very easy. Iron oxide, it's easy. Zinc oxide, easy to extract it. But we have to convert to oxide. So the second process is what? We do smelting. Heating any other copper ore such as sulfide and carbonate in presence of oxygen gives you copper oxide. This process is called as roasting. Is it clear, everybody? Everybody clear? The same thing. Once you get the copper oxide, we add sulfuric acid, we get copper sulfate. Copper sulfate, we are doing electrolysis to get copper. Understood? Fine. Maximum ore. Now write down. Maximum ore of copper is copper sulfide or carbonate. So 80% is this process we do. Everybody's clear? Somebody is not clear, please tell me. This part, the market important, right? Important. Is it clear? Fine. Now see, they're asking what? They're asking that. The second question, see. The question is that in the electrolysis, what we do? In the electrolysis, write down this, electro refining. What we do? In the electro refining, we take the pure copper rod at the cathode. You can write down this. Understood? We take the impure copper to be electrolyzed at the anode. Note down this part, right? Clear? There's a picture over here. You mark it important. Understood? We are purifying copper. Understood? We know now copper is obtained 95% pure. We are going for electro refining or electrolysis. How do you do? We take a pure copper at the cathode. We take the impure copper at the anode. This contains impurities. Can you see this? Understood? This thing is there. The question is that which electrode? Can you see this? Which electrode does pure copper collect at? Pure copper collects at the cathode, right? You can write down this part, right? Understood? See, write a balanced chemical equation including state symbols for the extraction of copper from copper sulfate by displacement. See, 3 marks. Rollicking, right? Fe is solid plus copper sulfate. Scrap iron, right? The scrap iron. Aqueous, you write AQ. Then you write what? FeSO4 AQ and CuS. Is it clear, everybody? Fine. Clear? Is it clear? You have to see that electrolysis will be challenged over here, right? Just Janki, please send me up a message. C6 and C7 to revise. C6 and C7. Go for a revision. What I'm telling you, revise. You've got other subjects also to study. I know. In between, punch in C6, C7. C8 we have already done. You're already expert in rates of the reaction and the equilibrium, right? Punch it in, right? Those students who have missed the equilibrium session, you can go to the recordings. Go to the recordings, right? It's not that you join me. It's not a financial thing which I'm doing, right? Please, everybody. I have gross students, please. I send those recordings. There are 2 students who could not join for some reason, right? So I send them. Thank you. Is it clear? Now see, 6 marker. See how copper is extracted by phytomining. Why this is increasing in important? Phytomining. See, we take the plants and grow it in the soil, and after that we cut the plants. We burn it. This copper ash is taken and treated with H2SO4. We get copper sulfate. Then what happens? We add scrap iron. We get FeSO4 plus copper. This is impure. What we do? We do electro refining. This is electro refining. See, isn't it clear? 6 marker question. Now I forgot to tell you. Everybody open this book. What are the disadvantages of this process, phytomining and bioleaching? One disadvantage is a very slow process. It can take years to extract 50% of the metal from the low grade ore. This is very important. Slow process, very slow process. Other than that, it's fine, right? Is it clear? We are using some ores which is not used by anybody, right? It's scrap, right? Low grade ore is scrap. Nobody touches it. Everybody's clear? This part is clear, everybody? Fine. Fine. So this part is just make sure that just to those students, electrolysis chapter, you go through it, right? Your 15th is your exam. I'll be joining with you either on 13th or 14th, right? Remember this thing, right? Either 13th or 14th, I'll be joining with you. Just 1 minute. Just give me 1 minute. 13th or 14th, I'll be joining with you, right? Fine. Thank you. So anyways, thank you so much. Let's take a break now. We are taking a break of,